Alright, maybe you guys can hear me there as well. Let's see how this is going. I'm trying to set up the camera here. Oh dear. Okay. Anti-flicker, image, sound, image. Okay. No. Okay, add the filter. Okay, yeah, I think that's reasonable. Why don't we try that, eh? Why don't we try that? Oh, folks, David here, Terrain-Tronics, just getting set up here. Today I am, so the other day we built this, and now I'm wiring it up. So these are 3 magnetic sensors that are used to, yeah, it is coming through, there we go. Yeah, magnetic sensors used to detect magnets, so when the gate moves up and down, there'll be a magnet on it, and when it moves past one of these, it knows it's gone to the top or the bottom. And then this one is for the player detection to move things. So I wanted my wire wrap tool. And is my Amazon working? Hey Alexa, play some music by the Brand New Heavies. I don't know. Who cares?
I don't know why. I Love You by the Brand New Heavies from Spotify.
There we go. Alright. So, yeah, the whole reason everything's blurred, this is my messy garage, so here you go. Let's have a look here. Okay, let's have a look here. This needs to be, there we go, it's called focus, 3.3 volts. Now I'm actually using a, start recording. Alright, so this is the prototype I'm making. Again, 2 magnetic sensors to know when the gate is lifted or fallen, and then this is the player detection one. Now, why am I building this? So John at Tabletop Witchcraft is building, the proper one with foam and everything else, but he needs me to help him with some code. And so what I'm going to do here is I'm building something I can just use on the bench, and just occasionally change the code and so on. So I've got like a dumb one without foam essentially. What you're seeing here, this is a little power strip PCB which I had made pretty quickly, and what I'm doing there is I'll show you what these look like. They come in kind of strips like this, and you know, let's say you put power and ground on one, then the next 4 of them also have the same thing. And the nice thing is, these actually come in strips of, let me cut it down a bit more, these actually come in strips of 3. There we go. So let's say you put power and ground up here, so you put your 5 volt or your 3.3 and maybe your ground black there. There's actually little jumpers here. If I put a blob of solder on there, then the signal continues all the way down to the next slot and even down to the next slot. So if you do have a setup with a lot of different boards, you know, where you need to run power and ground to all of them, you just use the power strip. And in this case, all I did was snap off in this joint here, snap off one of the boards. Really useful. I'm going to be releasing them pretty soon. If they are of interest to you, you know, come along, comment, comment in the chat here, or go ahead, let me know, and I'll hurry my way into getting them online onto the store. They shouldn't be very expensive. All right. So for this one, there's a. Let's see if this can be captured. There's a Wemos D1 mini board down here, and that's taken care of. You know, that's the brain of the system. By here is the new Kilgarren board, which has got a little motor driver on it, and we're going to use the motor driver to lift the gate up and down. Here's a whole bunch of high power LED outputs. We're not actually going to use those. We are going to actually reuse some of the pins instead as these inputs. So that's why you see these 2 wings of pins on the side here. Let me bring that up to the camera a little bit more. Does that work? Here we go. Yeah, so you can see there's, I kind of bodged it a little bit, but brought some extra pins in, okay? So along the sides here I've got D6, D7, D8 and 3.3, and then over here I've got 5 volt ground on this pin here, D4 and D3. So now what I'm going to do is I'm going to run ground from this pin here over to the power strip, and then ground to each of these as well, and you're going to see how quickly and how easily that can be done in. Oh, what time is it? It is 8:10 in the morning. We are getting the job done here. Okay, let's move down the bench here. There we go. All right. Okay. So I'm going to run a wire from here. That's going to come under the board here and plug in by here. So let's give myself a little bit of wiggle room. One end needs to just solder tapped here, so I'm just going to strip this wire. This is wire wrapping wire. On Amazon it's called Hookup Wire Kit. And I'm just going to strip off just a couple of millimeters, not even 1/8 of an inch, a little bit less than that, maybe 1/16 maybe. Okay, and soldering iron on. I forgot to put that on, so we'll give that a minute. And then the other end is going to wire wrap on by here, so we're just going to give that a little bit more wire because wire wrapping takes a little more. There you go. Now I'll wire wrap at the end, once I've got things hooked up here. Now let me rotate things around here because I'm right-handed. I'm going to use a pair of tweezers here to hold the wire in place. That tends to be a little bit more accurate and so on. If you are watching the stream, come keep me company. Say hello in the comments, yeah. If you have any questions on how this build is going, if you're joining late, this is once again not a drawbridge, a palisade that's got like a gate that picks up and down from Mordheim. A collaboration with John at the Tabletop Witchcraft, and it's essentially, there we go. This should be up to temperature now. So all I did with this little power supply board is you know, I've hot glued it at one end, and then I put blobs of solder on each of the pads. And again, I can show this off a little bit. Just simple boards like this, that's all it is. So, alright. Wire wrap. Okay, wire wrap that on. So now I've got ground going over to the power strip and power. I need to run now ground to the 3 little Western lights. These are magnetic sensors that work. That work, thankfully. I know I sound surprised that they work. Okay, so that's going to go there and come around to here. And I'm going to, one more thing. So if you guys have any advice on how I can spice up these live streams or anything like that, also let me know. Okay. Here we go. Now, one of the reasons for doing it this way, again, this is for prototyping. Yeah, I'm building this so I can start writing code. This doesn't need to be mechanically stable. You know, it's. I mean, there's hot glue holding stuff down. I may hot glue the wires in place as well, but as long as they're, you know, kind of solder tacked in place, I think that's more than enough for the application in this case. All right. Okay. Now this one's going to be a hard one to do because I've got that board in the way. Let's see if I can do this. There we go. When I first started doing a lot of these boards with pads on them instead of holes for putting in wires, I think a lot of people freaked out, but it's so fast. It's so fast when using wire wrap. Let's turn this around. There we go. Okay, and then finally, yeah, one more up there. So I'm going to need a little bit more of the black wire. Let's pull that. There we go. It's going to come from there over to there, so it's not very long. So when I'm writing the code, one of the things I want to write is something that writes back to the PC when it's plugged in that says, hey, you know, we always have, you know, whenever there's a magnet present, like what the magnet status is for each of them, so that as I'm debugging, then I can say, okay, you know, the system knows the magnet is there. You know, it's just being annoying. You know, it's just not knowing what to do with that presence of magnet. So that's one of the nice things about Arduino is, you know, you can write anything back to a PC. You can write any text messages back, and the PC will just show it on the screen, which is really useful when you're, you know, trying to work out what's not working. Okay. grab the tweezers. Ooh. Okay. So, I do need to make sure that none of the reds are touching the blacks or whatever, and I have no shorts, connections across this power strip, because otherwise that would mean I've got 3 volts going straight to ground, which would make things quite warm and possibly allow them to fail. That would not be good. Okay, so I'll check that in just a minute. Until then, I think it's time to start connecting the signals out of these. So when a magnet is placed over these, they send a high signal back to the chip here. So I'm going to use some multiple colors now for this, I think. Let me see. Okay, so we'll start with yellow. So yellow's going to go to this one, down here. Let's get my tweezers ready. There we go. And there we go. So there's one. Lovely. What color should we do next? I think green shall be next. And then we'll do blue. I really want to avoid using red or black because I use those as my sort of standard power colors. Okay, there's green. Maybe I can do this without tweezers. Let's see. Okay. So in the code, what we're going to do is, when there's no one standing here, then the motor, and I'll show you the motor in just a few minutes, is going to turn anti-clockwise, right, and let the gate drop until the magnet touches this. So in the code, it's just going to say keep turning and turning and turning and turning and turning until it sees this magnet, or the magnet over this point here. And then, in addition, then when there is a magnet over here, a player standing on it, then turn clockwise and pull the castle or the crane up until it sees this magnet. And what I may do is limit the amount of time. Once I've learned, once John builds the build and we know how long it takes for the on average for things to climb. Let's say it takes 5 seconds for the gate to climb. Maybe have it so that it can only run for 5.5 seconds, so that if the magnet does fall off or something like that, it doesn't rip everything by overturning the string and so on. That's a concern I have. Right, these types of systems, right? When you're building stuff with Arduino, you have to assume that it's dumb, and it only knows things it can see or read. Right, so you have to put in these other ideas on these other defensive design techniques. All right, so that was yellow and green. Let's get the blue. And what we'll do a little bit later, if I have time, is I'll jump on stream to start programming this thing as well. That might be fun. Okay. Okay, let's try this text message. Oh gosh. Oh, family stuff. Okay. Excellent. Excellent. Let's keep rolling here. And sad, no comments. You know, if anyone is watching, you guys are welcome to say hello at least. You know, it's getting quite quiet here talking to myself. There we go. Oh, okay. Let's move that out the way for this job. Okay. 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 So now I have a blue, a yellow, and a green. And the question is, what pins do I connect them to over here? I did have a... What do I want? I want an email that I sent to John that had the wine diagram. I'll see if I can show you that in just a moment. Okay, Gmail. Sent items. John, there we go. Let me see if I can jump scene here so you guys can see it. One. Let's just bring this over here then. There we go. So this is how the system's going to look once it's done. So I've got the motor right here, which we'll get in just a minute. There's a top of gate, a bottom of gate, and a player position. The GM override, I've decided not to use that. So top of gate D8, bottom of gate D7. Alright. Alright, so top of gate, bottom of gate is going to come over to here. So green comes down and around, and absolutely freaking typical. I didn't make the wire long enough. Okay, alright. These things are sent to test us. Let's change our diagram a little bit then, because it's all software, isn't it? So D3 and D4 are available for these two, so let's just use D3 and D4. Shit, come on. There we go. Now for those of you that have never used a wire wrapping tool, this is going to change your life. This is the way of rapid prototyping. There we go. Oh, is that Cross I see in chat there? Give me a second, Cross. D8, D7, you sacked my battleship. Yeah, you're aging yourself there, Cross. Definitely aging yourself. I'm not sure how many kids played battleships, you know, in the old school kind of plastic fold-out things we had as kids, right? I'm sure it's an app these days. Or a mod for Fortnite. Alright. So D8 and D7 in this case are pins on the board that when I'm writing code a little bit later, I could say, hey, if you see a signal, if you see, you know, a positive voltage on D7, D7 or D8, it means this, and do that. That's basically it. Oh, I love me some wire wrapping. Elegant, strong, and it just works. Alright. There we go. Yeah. Let's have a look here. So Cross, you might like this little guy. John got quite excited about this. I didn't understand why until I saw him use it in a build. This is a little power strip I've built. It's just a little circuit board that, you bring like the power into the left and right, and then every little pad underneath it then also has power and ground. So if you do have, a few little boards in different places, like sensors like this, they're really easy to power and so on, right? Rather than trying to share power, wire wrapping lots of wires on the same pins and stuff. Alright, I should document what I've done, shouldn't I? So why don't I grab a pen and on here write top gate, top of the gate, bottom gate. Oh, this ink is just running everywhere. Oh well. And this is player. There we go. Yeah, that is absolutely rubbish. Oh well. And maybe this is going to blue goes to D4. And then this top gate is going to D3. And this is going to D8. There we go. That'll help me later when I'm sat there at the bench. Plunk down, say a brazier, and a fire instant gets power. Good stuff. Yeah, that's the idea. Actually, John's idea for the game is, there's a gate coming into the city. If you want to keep the gate open, one of your players in your team has to keep standing on the spot. So you're kind of sacrificing. The that player from being able to run further into the city and so on. I think it's quite a clever, interactive dynamic, right? It's do you want to keep the door open to let more of your team through, or not? Or do you need that guy to run up front? Which of your team in Mordheim do you want to do it? You're not going to waste your tank type player, but maybe you put a sniper up there, right? So that he or she can snipe as well as do other stuff. Anyway, so let's go find a motor, wire that in, and then I think we'll be ready to jump and write some code and so on. Give me a sec. I'm going to jump off camera for a sec while I run to the other side of the garage. Plunk down, say a brazier, and fire instantly get power. Good stuff. Yeah, these little sensor boards are awesome for that. They have 2 holes for LEDs as well, so they'll light up an LED. A simple LED. If you want more power than that, you got to work harder. Okay, motors. Was a motor. Motors next to it. Okay. Okay, let's switch this back on with the camera. There we go. So there's the motor I'm planning on using. Let's see, there we go. And this is I think it's a little 5-volt one that's geared. So instead of spinning at like 15,000 revolutions a minute or whatever it does, it gears it down to about 15. So it's a relatively slow turning, and so there'll be a string that'll run around it and so on. So let's get the hot glue gun out, because all I'm going to do, I think, is just sort of glue it on here, just so I can make sure it's turning and things like that, or maybe like that. Yeah, that'd be nice. And then what colors shall we use? We don't use red and black because those are power. And in this case, you know, power is typically, you know, power is one direction. But because we're going to change what goes high, what goes low to make it turn different directions, we will use yellow and blue. Spicy. Spicy, spicy. Why is it so spicy? Doodle-doo-doo-doo-doo. Alright, I'm just doing some very basic tack soldering here. I'm wiring it up right now, but you know, because this is for development, it doesn't need to be strong, doesn't need to be perfect. It just needs to work. How's the quality of the stream, Cross? Because from what I can see, I'm getting a warning that the stream's current bitrate is lower than the recommended blah blah blah. Does it look okay? Do I sound okay? Just checking in, you know? Okay. Let's get this warmed up. Okay. Quick blob of solder on there. There we go. Quick blob of solder on there. Lovely, we're in business. Okay, let's get the glue gun on. The glue gun is coming up to temperature. And let's just, I think I'm just gonna do that. Yeah, let's just do that. We dab of glue. Actually, I'll put it on the wood, not on the metal, because it'll cool too quickly on the metal, right? If I put it on the wood, that'll insulate it for a second, and it won't instantly cool it off. Lovely, look at that. Fine, on our end I always get that warning, but I'm on Wi-Fi in my workspace which shows the quality. Ooh, that's interesting. I ran, in my messy garage here, I ran a gigabit cable, you know, up and around, and I tend to, you know, make stuff work before I make it look pretty, so, as you can see by my work here. Okay, come on. There we go. And we'll wire up this on. Gosh, if this works after I'm done, I'll be amazed. Okay, so that's one. Okay, and then the other. There we go. Beautiful. So I think sensor, yes. Motor, yes. Brain, yes. Power strip, yes. So last thing to do now, is to make sure before I plug it into a PC and take the PC down with it, make sure that I haven't shorted anything. So I'm not sure if you're familiar with this. This is a multimeter, and they beep and squeak, and they all have this kind of symbol on them, which is a continuity tester, which if I, you know, connect these together, if I touch these two probes, it tells me that, yeah, you know, they're connected electrically. So, for instance, if I say, hey, I want to check that this is connected, right, this power over here, I'll come back to here and, ooh, there we go. Yeah, that's good, that's good. Okay, I'm happy with that. One of the things to check here is that the ground and the power are not touching. And in fact, it's not beeping, but it's, what's it telling me? That there is a connection, but it's not very. That's fine. 400 ohms. That's probably enough just to power the board itself. So, you know, as in, yeah, there is a connection, but there's normally lots of chips between power and ground. So I'm not too unhappy about that. What else? Let's make sure power is getting from the board. So power is coming from this pin here. Lovely. Ground is coming from this pin here. Lovely. Yeah, ground. I got a couple of points here as well on the board. Lovely, lovely, lovely. Okay, I think that's enough for this morning. I think next time you see and hear from me, I'll be in the comfort of my office, another messy place, writing code. And we'll see if we can make this motor spin or not. Alright, thank you for joining me today. Yeah, I really appreciate it. Yeah, I might be on a little bit later. Oh, hey, Scott, how you doing? You just catch me at the end of this one. You know, I had a little time this morning. The family were off to school early, and I thought, all right, then you know what? I need to, you know, John is pressuring me to get this code done for his Mordheim build. So this is my little prototype that I can, you know, work on at, you know, at my office table. Yeah. So, you know, I don't want to be sat there building up foam and things like that, you know, if I don't need it to write the code. So I'm going to fake it like this, just placing magnets on top at different times and so on. All right. You guys take care. Lovely seeing you both pop up. Yeah. Maybe I might be back on later on this afternoon if you guys have any downtime. Yeah, make sure you're getting notifications from YouTube. All right. Take care. Bye.